Alright, so Unit 4, we're solving quadratic equations. So before we only looked at factored form, but we need to be able to solve quadratics in any format. So if we look back, we've graphed quadratics from vertex form, y equals a bracket x minus h bracket squared plus k, where h and k were our vertex, and we moved our step pattern. And then we also graphed from factored or root form, y equals a bracket x minus r bracket and then the other bracket x minus s, where r and s were our roots, and we could find our vertex halfway between r and s and divide by 2. Okay, so add them and divide by 2. That gave us our h value, our axis of symmetry, that we could then plug in for x and solve for y, our k value of our vertex. But what if the equation is in standard form, y equals ax squared plus bx plus c, and it doesn't factor easily? What we can do is we can put standard form into vertex form by completing the square. So what you're going to do is you're going to take the first two terms, ax squared plus bx, okay, so the two variable terms, and we're going to make those into perfect squares. So we divide the middle term bx, okay, we divide it by 2, we're going to square that coefficient, and then add and subtract that value inside the bracket. Okay, next we remove the subtraction from your brackets, so now you'll only have 3 terms in the bracket instead of 4. And we'll simplify what's outside the bracket and factor the bracket, which is a perfect square. So looking at example 1, let's put this into vertex form, y equals x squared plus 14x plus 6. And we want to say, okay, well, can we factor that? Could we just do it that way? Does anything multiply to 6 and add to 14? And no, it doesn't. So what we need to do is we need to complete the square. Alright, so now if we look at x squared plus 14 plus 6, sorry, 14x plus 6, you're going to take the first two terms, x squared plus 14x. We look at the 14x, okay, we take half of it, so we get 7, and we're going to square that. So we get 49. So that's what we're going to add, and we're going to subtract. Okay, so now what we've done is we haven't really changed the original quadratic equation because we've added and subtracted the same value. So then we can take this subtraction out of the brackets by not changing anything. So now we just have a perfect square of x squared plus 14x plus 49 inside the brackets that will factor, and then minus 49 plus 6 outside the bracket. So now we can simplify. So we simplify what's outside, we get minus 43, and we factor x squared plus 14x plus 49, saying what multiplies to 49 and adds to a positive 14, and that's 7 and 7. So then we have factored it to a perfect square of x plus 7 times x plus 7. So x plus 7 squared minus 43, and we've now changed a standard form equation into vertex form. We can see that the vertex is negative 7, negative 43, and then we can also notice that the step pattern is a positive 1. Okay, so now I want you to try example 2. I want you to change y equals x squared minus 8x minus 2 into vertex form. So pause the video, try and fill in the steps, okay, and then press play on the video again when you're ready to check your answer. Alright, so now if we look back, remember you took the negative 8, you took half of it, which gives you negative 4, you squared it, which gives you 16, so you're going to add and subtract 16. You then take the 16 outside the brackets, and you leave the addition of the 16 inside the bracket. We can now factor this, and sorry, there's a typo on this. The squared should be there. Okay. And then we can factor this so that we're saying what multiplied to a 16 and added to negative 8. So that was negative 4 and negative 4. So we can see that this is a perfect square, x minus 4 in brackets squared, and simplifying what's outside we get minus 18. So our vertex is at a positive 4, negative 18 with a step pattern of 1, 3, 5. So now we're going to move on To example 3, what if there is an a value in front? So the first thing you always want to do is factor the a out first from the first two terms, and only the first two terms. So I want you to try example 3. You're going to factor out the 3 from the first two terms. Okay, so when you do that, you can then try and complete the square. So go ahead and try that, pausing the video, and then come back. Alright, so notice that we factored out the 3 from the first two terms, so it became 3 bracket x squared minus 8x, because negative 24 divided by 3 gave us negative 8. So now we're going to take half of the middle term, which is now negative 8, so that gives us 4 squared. So we're going to add 16 and subtract 16. The next step, where you have to take the negative or the subtraction outside, you have to remember that you factored a 3 from your brackets. So in order to remove the subtraction, you actually have to distribute that 3 that was in front back to it. So it actually becomes 3 times negative 16. So you still have the 3 terms left in the bracket to factor, so what multiplied to 16 and added to negative 8, and x minus 4. And then 3 times negative 16 gave you negative 48. So when you simplify everything, 3 bracket x minus 4 bracket squared minus 38 is your vertex form. So a vertex of 4, negative 38, and a step pattern of 3. So instead of being 1, 3, 5, you'll have 3, 9, 15. So now what I want you to do, I want you to go ahead and try example 4. Pause the video and then come back and check. Alright, so remember, you're factoring out your a values, so negative 3, it leaves you with x squared plus 6x, because negative 18x divided by negative 3 gives you a positive 6x. And then remember, you keep your last term the same. So now we're trying to think of, okay, well, what do we need to add and subtract to x squared plus 6x to be able to make this a perfect square? So you take half of 6, which gives you 3, and we square that, so we're going to add and subtract 9. So we can see that we're going to have y equals negative 3 x squared, and then plus our 6x, and now we're going to add 9 and subtract 9, and then we still have our minus 4 outside. Next, we need to take our negative out, so when we're actually taking it outside, we're going to multiply by the negative 3. So we have y equals negative 3 bracket. We're still going to have our x squared plus 6x plus 9. But now, when we take out the negative 3 times the negative 9, we're going to have plus 27. Again, that's from the negative 3 times the negative 9. And then our minus 4 still remains. So now we can factor what was left in the brackets. Oops. So y equals negative 3 bracket. What multiplies to 9 and adds to 6? We'll have x plus, same sign, oops, x plus 3 in brackets squared, and then we simplify plus 27 minus 4, which gives us plus 23. So we can see that our vertex is at a negative 3, positive 23, with a step pattern of negative 3. Okay, oops, there we go. Okay, so vertex is at negative 3 comma 23 with an a value of negative 3. Alright, so that's it for today. I want you to work through now your knowledge and understanding questions. So turn into your textbook on page 270, and I want you to complete numbers 2 to 3 EOL. In class, we'll work through the remainder of the puzzle problems, and then we'll also continue this on the other day with some more examples tomorrow night.